for somebody to come in here. If anybody comes on in, I'm adding in here. I'll send another invite out. To all you guys. I'll post it on Google Classroom so you can see it, and just trying to get it all set up, and I'll start with what's going on. I want to talk about piecewise functions, and what happened today in class, we didn't really get a chance to get to everything we needed to get to. So I'm just kind of waiting on some folks to get here. I got an email, so what I'm going to do is I'll go to my phone and check and see if anybody shows up. Let's see what's going on here. I believe it looks like you got to have the app. I'm kind of joining myself here. That's feedback from me. Sorry about the feedback there. That was me trying it. Got 2 viewers. Let's see if I can kind of get my information here. And let's see if we can see this. All right, what I'm going to try to do here is I want to try to go to Desmos and make sure everybody kind of understands what's happening. Thanks. All right, here I am on Desmos, and guys, what I'm going to do is I'm going to think about what we talked about today. See if we can build from there. Okay, we've got a graph here. So if I graph a linear equation, the one that we did today was a linear equation. So if I graph x plus 4, okay, and you were going to work with this graph, what you would do is you would have a piece of graph, you'd have a piece of paper, you'd make your graph. You go to 4, you go to 0, 4 right there because that's the y-intercept. Okay, and then your slope is 1. So you go up 1 and right 1, up 1, right 1, up 1, right 1. And that's your slope. So now if we wanted to make it piecewise, if we wanted to put some restrictions on the domain, remember the domain handles the line left and right. So I'd put something like x has to be, I don't know, greater than 0. And so that's that line that goes up and to the right. Yet today, when we graphed this in the class, I think somebody said y equals 4. They had a horizontal line that went at 0. This line here is a horizontal line, and even if I put the restriction of x is greater than 0 on it, sorry, put those brackets in there so it knows how to deal with that. See, that would be that line straight, but this line has a slope of 4. Now, if I change the slope here to 1/2 maybe, it changes that equation, but x equals 0 goes off to the right. Okay, I can do 1/2 x plus 4, and then go to 4, go up 1 over 2, up 1 over 2, up 1 over 2. And that controls how that line is graphed to the right. Now, if we zoomed in here, because remember this is greater than or equal to, around 4 there would be an open circle or a closed circle. If I wanted it to be a dot, see how I put the dot in there? Put the dot right there because I went to greater than or equal to. That's how this format shows the difference between just plain greater than and greater than or equal to. And it's greater than or equal to, so it's going to the right. If I turn that to less than or equal to, it would be the same line, but it would show over here to the left. Okay, so now let's graph a quadratic equation. So a quadratic equation would look like this: y equals x squared. Okay, and so now there's that's the whole thing. If I wanted to restrict the data, okay, if I wanted to come up with just the piecewise part, I'd go x is greater than or equal to 0, and greater than goes to the right. If I put 0 there, let's type this correctly here, sorry. And that goes off to the right. How could I turn that part that's going off to the right upside down? Put a negative in front, and now it goes off. It opens down, but it's still the part of the graph that's to the right. I could move that. I could move where it starts over by changing this number from 0 to 1. So now it would start where x is 1. See, this is where x is 1 right here. Let me show you the line where x equals 1. So it starts right there at 1. If I made this 5, it would only show the part over. So I'd have to move over here to where 5 is and go way down there, because think about what 5 is. 5 is there 25. Here's 24, so that's 25. So it would start right there. So go back up here to 0 and see if we can't follow the logic of what's going on here. So let's go less than 0. So that's the part that's on the left. Now we wouldn't want to graph this as a piecewise function, because is that a function? This picture right here is not a function, because this would fail the vertical line test. Okay, so if I wanted it to pass the vertical line test, I got to make one of these greater than, one of them less than. And so now I can make one of them greater than or equal to. Wouldn't want to make them both greater than or equal to, less than or equal to, because that means 0 would be, and it would fail that. It would fail the vertical line test right there at 0. So even though that would be that, it would not work as a example of a function. All right, does anybody got any questions? I see there's two other viewers on here who can't quite tell. I don't believe who that other viewer. Yeah, there's no way for me to tell who it is. It's just somebody. You can go up here in the upper right and click over. So right there, see, I picked up a third viewer right there. I can go through and explain what I did again. if that would help you. Okay, I'm trying to see who's in here, and don't necessarily, I can't. Right, I'll go through the process here again and see if I can't show you what I did earlier here. All right, what we've got here is we've got two graphs, and graph y equals 1/2 x plus 4. Let's go back to the start of this picture here and see if we can't figure out what's going on. If I take the restrictions off of this and I go ahead and turn this one off, let's kind of pretend like it's not there. I could add a folder to put it in and see it. So I'll hide that line like it's not even there. Okay, this is the next equation. What I've got is I've got a linear equation right here. And this is graph and linear equations, just like when you were in a younger class. This is 0, 4. So I go to 0, 4 right here. I put a dot on the graph. There's 0, 4. That's my y-intercept. My slope is 1/2. So I go up 1 and over 2, up 1 and to the right 2. If I make this a negative here, now the line's going in the other direction. So now what I wanted to do is I wanted to do what we did in class today, which was to restrict the value here. And so to do that in Desmos, you have to use braces. So I do braces, and then x is greater than 0. And so because it's greater than 0, it's like we talked today. When you do greater than 0, it'll be the graph to the right. When you do less than 0, it'll be the graph to the left. And I can change this number to any number here. And it would go to 1, it would go to 2, it would start at -2. But again, the way you graph a linear equation has nothing to do with this part. It has to do with the 0, 4, and then the slope being -1/2. So you go down 1 and right 2, down 1 and right 2. You draw your line in there, and then you just take your pencil and would erase it at -2, or erase it at 0. Okay, and so now let's bring in the next equation. Well, the next equation is a parabola. Well, if we had the parabola opening up, it'd be a parabola right here, and obviously this is not a function, so it wouldn't be an example that we would necessarily want to use because it would fail the vertical line test. But if we take this right here, and if one side is greater than and the other side is less than, watch what happens when we get less than. Now we have something that is a function, because it's not 0 is not on either one of those lines, and so you do the vertical line test and it passes, and so that's a function. So that's a good example of a piecewise function. So I could write this using f of x in my two things. Watch. Here, less than is on the right. Less than is on the left. Greater than is on the right. If I want it to turn down, put a negative in front of it. Now it opens down. If I want this equation to go up 5 and over 1, put a positive 5 in there. Then I'd go to 0, 4, just like I did when I was in Algebra 1, and I'd count up 5 and over 1, put another dot. Count up 5 over 1, put another dot. Imagine in your mind you graphed the whole line, but I'm going to take off the part that's 0 to the right. All right, let's see if I can go back here now and see if I have any questions. This is all these things that I usually have access to are disabled because it's about to change. This concept is going to YouTube Live. So it'll be on YouTube Live. Let's see if I can't just chat here. If you look on the left hand, if you go down the left hand side, the chat box up at the top, you can click on that chat box, and then over here on the right, you can ask me a question or anything. Can I help anybody? Well, that's a little bit longer than I wanted to stay on, so it looks like I got one viewer in here with me and not asking questions. So if there's not any further questions, I believe I'll go ahead and end the Hangout and see where we can go from here. All right. Nice talking to you guys.